Have you ever wondered if you could teach your computer to play Bloons TD6? Well, I did. Here's the story of how it went. First, what even is Bloons TD6? Bloons is a strategy turn-based game where your goal is to defend oncoming waves of balloons by placing and upgrading towers around the map. The map is typically defined by a path that is followed by the balloons trying to get to the end. Once the balloons get to the end, you will lose the lives until you have none, in which case you would lose the game. There are multiple types of balloons in the game. Different categories include the normal balloon, the steer balloon, the camouflage, and regenerating balloons. Each of these balloon types has different attributes and features. For example, the steer balloon can only be destroyed by explosive towers. The camouflage requires special upgrades so that the towers can see him, and the regenerating balloon needs to be destroyed quite quickly as it will regain its health. There are also multiple types of towers. Actually, there are quite a lot of towers in the game. However, for the simplicity of our AI, we're gonna focus on two types: the dart monkey and the bomb shooter, also known as the cannon. I picked these towers because with the certain upgrades, they are capable of destroying all of the different balloon types we will face in our basic level. So that's the basics of the game out of the way. Now let's focus on implementing a Python script that is actually able to play the game. First, we need to be able to tell our Python script certain values of the game. One of them is the lives and money displayed at the top left of our game. We do this by using optical character recognition and certain filters so that our Python script will read those values constantly from the game. Next, we need to find a way that the Python script knows a round is running or finished. For this, we look at the bottom right for the play icon. The play icon varies in two ways. The first way is that by showing one triangle, which indicates a game being between rounds, so not running, and if shown two rectangles, the game is currently running. By simply drawing a rectangle around the triangle, we can calculate the axis of certain corners and by that determine if we have two triangles or one, or better, if the game is running or being paused. Next, we need to tell our game where he can place towers and where the path is running. For this, we generate a NumPy array of the same size as our game playing window is gonna be. We then assign or manually draw by hand the path on the map. It's currently seen in red, assigning it the value 1, as well as areas where certain UI elements are, so something where we cannot place a tower, assigning it the value 2. We then assign the remaining places the value 0, indicating to our game playing AI that these are spots where it can place towers. If we look at the drawn array or the array we created, we see that the path of the map as well as certain non-placeable areas are clearly marked and can be used or interpreted by our Python code. Alright, and that's the basics of the game implemented. Now let's take a look at the AI we are gonna use. For the purpose of our game playing mechanism, we're gonna use something called a genetic AI. A genetic AI is based on the concepts of biology, combining different attributes that are typically found in evolution theory. First, we're gonna create an individual is one representation of all the actions our AI should take during one game, so all the 40 rounds. These actions can be placing a dart monkey, placing a cannon, upgrading a certain tower, or waiting. When we look at those sequence, it's a sequence of 40 actions representing one round each. Next, we combine these actions or individuals together into a population. Population contains 1,000 different strategies, so 1,000 different ways our AI can play the game. Next, we need to find a way on how to evaluate each individual. For this, we use something called a fitness function. The fitness function is basically a mathematical formula that evaluates certain qualities of our strategy. For our purpose, we're going to look at the placement quality, so how many path pixels are within the range of the tower. The upgrade values, different upgrade paths can give different values. The economies, so how efficient the AI is spending money. The tower efficiency, if the tower are covering good paths and are placed early. And also the success rate, so how many towers he was actually able to place. We are then going to use this formula to assign each simulation or individual a fitness function. Based on the fitness function, we want to use it to pick individuals that are particularly good and use them for further improved strategies. In genetic algorithms, there are two ways we can do this. One is crossover or array production, which basically states that we pick two good strategies identified by a high fitness score and switch certain parts of the strategy. For example, we could pick the first 20 rounds of strategy A and the last 20 rounds of strategy B. The other thing is mutation. Mutation is basically changing a random action. So we basically pick an action that is going to be performed in one round, for example, placing a tower, and change it to placing a different tower, or waiting, or upgrading. These things are all picked random and thus allow our strategy to explore new possible ways of playing the game. After these actions have been performed, we evaluate our fitness function again, but this time not only by using Python, but by actually playing the game. So we are going to load our strategy into our Python and execute the actions we previously explained. Then we are going to recalculate each individual's fitness function using a more realistic approach. This includes rounds completed, lives remaining, the money remaining, the number of towers placed and the upgrades applied, and also giving a victory or a defeat bonus should the strategy be successful. Given this, we evaluate all the strategies. Actually, it's not all of them, because playing a single round of Bloons is quite time intensive. We limit ourselves to the top 4 strategies that we previously already evaluated. That's the basics of how our algorithms and our Python code works. And we're gonna perform these things for multiple times, multiple generations, and see how good it evolves. The next clip is the final attempt of my AI being able to finish the first map of Bloons Tower Defense 6. Enjoy!